Welcome back to another episode of the Open Source Cafe. And today we have Or here with us from Permit.io, and we're going to talk about all things related to making permissions more accessible. Before we get started, Or would like to give yourself an intro, tell our viewers a little bit more about yourself and what you do at Permit.io.
Sure. First of all, really excited to be here. Kunal, thank you for hosting me. My name is Or Weis. My background starts in the intelligence corps in the IDF, where I was an officer, developer, reverse engineer, yada yada yada. Worked in a couple startups, was a VP of R&D in a cybersecurity company, founded another DevTools company called Brookout. During my time in Brookout, I ended up rebuilding access control 5 times when the company wasn't even 3 years old. And I just thought, that's stupid. I don't want to do it once, let alone 5 times. So getting together with Asaf, who's now my co-founder, he brought in some of his experience from Facebook, where he saw that they built access control with a team of 30 people for half a decade. We got together to create Permit.io, which essentially brings in the premise of you know what access control is. You've been building it 1,000 times over and over, and you don't want to, so you don't have to. We have a on-the-shelf solution that you can use, so you can actually focus on building your own product. And I'm just trying to take off that same pain that I felt myself when I'm focusing on my product, and remove it for everyone else. That's the basic story.
Yeah, thanks for sharing. And I'm really really a lot interested into hearing about what are the challenges that you saw in the previous companies that folks were facing when it comes to permissions. So, what were those?
Yeah, so there are multiple challenges, both in how you build access control. So access control or authorization or permissions, it's part of the IAM space. And as part of that space, it has a lot of requirements in terms of security, compliance, and just the stability of how you're building the product. It's actually, because of cryptography and other security elements into it, it's actually very easy to get it wrong, just in how you design or approach to building this. But I think the core pain is just the amount of work and amount of experiences that you need to deliver with any product you're building. I'll just name a few experiences, and you'll see as I name them that you've seen them before. And the sad story is that every time you saw them, some poor schlep of a developer had to create them from scratch. So things like user management with the ability to assign roles, API key management, secrets management, audit logs, the ability to see who did what within the system, for you to see it for as the entire system, and for each of your tenants, each of your customers to view it on their own. Multi-tenancy, approval flows, the ability to ask permissions from another user, emergency access, and the list just goes on and on and on. And again, these are not new things, but sadly, they've been rebuilt thousands and maybe even millions of times. So the idea with Pyramid is to take that off the table and to enable people to approach this without having to rebuild it, and with all the best practices in place. And maybe thirdly, that's the one of the challenges. Just kind of understand what's the right way to approach this and what is the wrong way. A lot of people get confused with just wrapping their heads around different types of policies. So everyone starts with, let's just have admin and not admin, right? And then you move to admin, not admin, and super admin. And then you move to access control list. And then a customer comes in and wants a role, so you add role-based access control. And then you get some more specific roles. You want it to be according to the role, but only if you're the owner of the file, or only if you're in the United States, or only if this is the time of day. And then you move from RBAC to RBAC plus, and then you add more attributes, and you evolve into attribute-based access control, and then relationship-based access control. And again, this element of how you build the policy itself is also constantly changing and evolving for every product you build. So just wrapping your heads around the different models that you have and how it changes for what you're building is a key part of it. Just the best practices of how to think about it and how to implement it either on your own or ideally with open source.
Thanks a lot for sharing about the challenges. And I know you're talking about in the Twitter space as well, so I definitely resonate with that. Can you share a little bit more about what Permit.io is and how it tackles some of these challenges.
Yeah, so I think at its core, Permit.io starts with open source and the best practices. So a lot of the challenges I talked about, their mirror image is a set of best practices that you can use to build on your own. But instead of building on your own, you can use open source tools. Some of them we created. And if you want to take it all the way to the end, so you don't have to deal with this at all, that's where you'll be using Permit.io. So at its core, we're using the open source components. Two key parts of them are Open Policy Agent, which is a very popular project we adopted and we contribute to. And on top of that, we have our own open source project, OPAL, Open Policy Administration Layer, which enables you to take multiple OPA instances and keep them up to date with the changes of your live application. So you want to update both your policy and your data. So policy is, for OPA, you write policy as code, and you want to manage that code in a Git repository. So with OPAL, you can just commit and push your changes into Git, and OPAL will automatically track that and propagate it to the multiple OPA instances that you might have. And the other part is data. So I'll give an example of where that comes into play. Let's say you want a policy like only users that have paid for a feature can use that. So that bit of information of who paid for something, that no longer just sits in your database. That sits today in a third-party service like Stripe or ChargeBee or PayPal. So you want that change to propagate quickly into your authorization layer. So when someone swipes a credit card, they immediately gain the access that they want and have a good experience. So Opal can track those third party or general external data sources and propagate the data from them into the policy agents so they be aware of the world picture as they are queried for access decisions. So that's kind of the core that we've built Permit on. And on top of that, we basically just added all those experiences that I mentioned before, all those uh, UI and API components that people keep rebuilding over and over. So there's kind of this core policy as code, open source management layer. And on top of that, all the different experiences that an application might need, a product might need. And with tools that, while translating to code, are low code, no code. I'll give an example. Our policy editor, it's basically a way to generate Wiggle code policies, but with a very simplified interface. You basically check boxes for the different roles that you want, that they will have different permissions. And I like to say that's an interface that a monkey can use or even a product manager. So the idea is not just to empower the developers, it's to help the developers to empower the rest of the organization, to give interfaces and experiences that are simple enough that everyone can chime in on the conversation. And the policy editor is one example, but there are many more.
Amazing. I like how you mentioned it's built on top of open source tools. And for folks who want to learn more about Opal, I made a video on it already, so you can check out the links in the description below. Um, can you share it? So Permit.io, it's like a SaaS offering,
Right.
sort of a things. Is there like a free version to it as well?
Yeah, of course. So it's actually very extensive. So up to 1,000 users, monthly active users in the system. It's completely free. And on top of that, it's basically how much you use. So the more you use, that's kind of the how we calculate your cost. So the idea is that we share an upside with you. If you're building a product and your product succeeds and you cater to more customers, you we win together, and that's what we're aiming for with anything we're building. We want our customers to be happy and their products to be successful, and so they can focus on making those products successful.
Amazing. And as you mentioned about OPA, you mentioned about Opal and Permit.io individually. For folks who may be
Mhm.
new to the terms, can you maybe share a little bit more about what are the differences between these three in brief?
Yeah, sure. So we kind of touched on it, but I'll elaborate. So there are multiple components here. The basic one we started with is OPA, the Open Policy Agent, which is essentially a decision making engine, a general purpose decision making engine. You load data into it in the form of JSON documents, kind of describing to it the state of the world. And you load rules into it or policies into it in the form of code in a language called Rigo. Rigo is a derivative of Datalog, which is a derivative of Prolog. Those are logical programming languages. Their advantage here is that the engine kind of guarantees that it covers all the rules for you. It runs for you recursively between all the rules that you write, so you have all your bases covered. And the engine itself is very optimized for this scenario for doing authorization queries. The challenge with it is keeping it up to date with all the policies and data that you have, and that's where OPAL comes in. So, as I said before, OPAL can track both Git repositories and other data sources to update in real time your different policy agents you might have. So you have, when you use Permit.io, we kind of bundle OPAL client and the OPA agent into a component that we call the PDP, the policy decision point. The term comes from the ZACML terminology. So you deploy the policy decision point next to your application, ideally as a sidecar. And that basically contains Open OPAL, and they become your way to update your authorization layer in your application. Next to it, you write your own code, and using your SDK, you connect it to that PDP. So, in essence, going back to your original question, OPA and OPAL are building blocks, are the basic infrastructure that permit users to create an authorization layer in your application in a scalable, real-time way, in highly available, highly secure, easy to use, yada, yada, yada. And Permit, on top of that, creates a lot of experiences that you can manage from the back office with UI and API, and to provide to your end customers so they can work with it directly. So to summarize, OPA and OPAL are basic components to build an authorization layer, and Permit is the authorization layer with all the experiences you need to manage it on top.
Can you also use any other policy agents along with Permit.io? Do you allow
Oh,
that?
that's a great question. So in OPAL, we really designed OPAL to support multiple policy agents. We started with OPA because it's I guess, the most mature and most popular agent out there at the moment. But I think from day one, knowing developers, we know that being polyglot, especially in cloud environments, is very common. Different scenarios require different tools, and different people, different teams, different developers have different preferences. And there are other cool engines out there. There's also, and there's implementations of Google Zanzibar. So we really designed OPAL from day one, and as a derivative of that, Permit itself, to be able to work with those multiple agents. It's essentially an insertable component. You can tell, as long as they implement the same API, you can tell OPAL, load this data and these policies into a different store. It's essentially a configurable component within OPAL. And we're planning to add official support within the project for more engines as we go. But we did start with OPA, and we do think it's a very cool project and a good default, at least.
Yeah, that makes sense totally. I was just asking in case, the point you mentioned about various tools being required for various tasks, maybe in the future, if not right now. So just happy to know that there is support for that. Cool. Can you, just my second last question, can you share about, according to your experiences, what are some of so you shared about the challenges that folks face. Can you also share some of the authorization best practices with folks?
Yeah, sure. I think we can maybe touch both on the best practices and the pitfalls, like what people usually miss, and kind of create a whole picture of that together. So I think the biggest pitfall people do when they come in to implement authorization is implement it on their own without learning the best practices or looking at existing tools. It seems like a very simple problem at the surface. I fell for this too multiple times, because you just when you look at it at a certain slice of time, you say, oh, okay, I just need a few roles, or I just need admin, not admin. There's no reason to start building complex things here, and so you start building it on your own without being aware of what the future might hold. And then a pitfall that comes with that is coupling your authorization layer or your authorization component with the application itself. So you can see, and actually we show it permit IOs on the front page. We show that because I think it really helps to understand the complexity of the problem. The difference between coupling and not coupling. So when you couple it, you essentially get spaghetti code. You get if conditions that look both at the logic of the application and the logic of the authorization layer. And it looks, at the beginning, it's kind of organized. You have like a simple end term between the two, and you can understand where it goes. But as time evolves, as time goes forward and the application evolves, other developers start adding more conditions into that if, and then when you want to upgrade either your authorization layer or the application itself, it starts to be confusing which part is which part. And you end up having to go line by line and refactor everything, which can be very time costly. Usually scenarios like that, you end up, instead of having a project that can take like a couple of days, a couple of weeks, you end up spending months on it. The mirror image of that pitfall is obviously to decouple policy and code. Essentially create a separate microservice for your authorization. Now, I highly encourage people to use an open source tool like OPAL or our own PDP to kind of create that microservice instead of building it from scratch. But if you decide to build it on your own, that's okay too. But you need to be aware of where things are going to be headed. So you want it to be a separate microservice, and you want it to provide a clear API to the rest of your microservices. It can
So
even be a
not
simple
building
function.
so not building it in each individual microservice, but rather than having it as a dedicated thing.
Yes, and then even if it's a stupid function, right? It could be a lambda function that always returns true. Like, do I have access? Yes. At least then, if you decide to add more rules there, they will be in a siloed, clear space, and it will be easy to upgrade. You don't need to run over your entire application now and do diffs and searches of where you need to change that. And better yet, if you decide that you want to swap in a ready project, you'll be able to do so easily because you have a clear API. And at the most, you'll just need to add a translation layer or an abstraction layer between your previous API and the one of the tool that you chose. And I think that's one of the most important things. Applications are constantly evolving, it's constantly changing, and we need to plan for the next milestone and not just the one that we have now. And with authorization, it can really get very complex very fast without us really thinking about it. Demands can come from weird places. I'll give an example. Working with Cisco in my previous company, they came in and they said, we want, after they onboarded customers to our product, they said, we want our own back office. We want to be able to control how we onboard customers to this thing. And then I realized there is no feasible way that I can take the authorization layer that I built and split it into two separate back offices. I just didn't plan for it. I didn't think that's something that's going to come up the road, but it did. And because I didn't decouple it, I ended up changing I had to change my entire product, not just a separate component. So that's just an example of where it can come from surprising angles that it's really hard to think of. And every application, every product is a snowflake, right? So you won't encounter the same exact problems I did, but you are definitely going to encounter your own set of unique problems. Another common pitfall that I see people run into a lot is kind of confusing authentication and authorization. First of all, the two really sound the same. So just for starters, it's kind of hard to say what's the difference between them. So just to clarify, authentication is identifying who's at the door. And authorization is once you decided to let them in and you know who they are, is deciding what they're allowed to do within your house, within your application. So one is about verifying identity. The other one is about authorizing actions or giving permissions. And this confusion can translate into how you manage this in your product. So most cloud applications today would work with some authentication solution that will produce a JSON web token, a cryptographically signed document that presents the identity of the user. One of the cool things that it has is claims about the identity of the user, which is essentially a block of JSON key value terms that you can just shove in there. So it can be very enticing for developers to just load more things into that. For example, let's save the actual role for the user in the claims, or let's actually save the permissions themselves. And God forbid, I actually saw people saving the actual routes, like which routes are you allowed to call or not. It seems okay, like a lot of things here. Initially, it sounds okay. Like, what's the big deal? But then you realize that more things are going to come in, and there's a limit of how much data you can shove into a JSON Web Token. There's an actual limit, and also it's important to remember the JSON Web Token is sent with every request. So the more bloated it is, the more heavy and slow your application becomes. And also other elements, like if you want to change, so the JSON Web Token is coupled to your identity and login. If you now want to change the permission, you need to re-verify the identity. You need to log out and log in again, which can also create a very annoying experience, or at least slow down your application. The best practice here would be to set a clear line between authentication and authorization. JSON Web Token, for example, should only contain the claims about who this identity is and not what it's allowed to do. You can use those hints, those claims in the authorization layer to then make those decisions, or at the sign-up stage, translate those claims into roles or other attributes that you use at the informant stage. But by setting a clear line, you give yourself your flexibility and you avoid running into storage and performance problems that you'll hit down the road. And it's easy to do just by setting those clear lines. Another best practice that kind of goes well with this is being event driven. So we already realized here that there's a lot of different data, attributes, and elements that we want to manage for our application. So instead of trying to shove it into the JSON Web Token, or instead of constantly polling different sources to kind of load it into our authorization layer, the best practice here is to be event driven. Most applications, modern applications, are event driven anyway. So when a new event happens, someone performs an action, someone buys the product, someone interacts with another service, we can propagate those events into the authorization layer so it can learn to update itself. Like the example I gave before, someone swipes a credit card. So we can get a webhook from Stripe and use that to tell our authorization layer, hey, go to Stripe, fetch the data that you need about who paid, or so when people actually come and use, you have the answer. And that way we can have that propagate in real time. So for example, if we do this in polling instead, someone swipes a credit card and then they try to log into the application, but they can't. They get an error that they haven't paid yet, even though they did, until the polling interval hits, and then it updates, and you just get a bad experience. But if you're event driven in advance, they swipe the credit card, the event propagates. By the time they actually go to connect to the application, it's already in sync. So being event driven is really a key part there. Another thing that developers, I think, often miss is who is going to be working with this. Initially, especially when you're just in the beginning, you're thinking, oh, it's just admin, not admin. So I'm the admin. Everyone else, they get just the basic permissions. That's it. So if I want to, so I'm in charge. So if I want to change this, it's me changing this. And I'm not going to change this a lot because I'm the only one that's going to get admin privileges, maybe another guy or gal if I trust them. But then customer requirements come in and they say, oh, we need roles and we need a specific role for this case and that case. And then what happens is that the product managers and other people in the company come in and ask the developer to constantly add these elements. So those get translated into a lot of tickets in Jira and development sprints that you have to do. As in the beginning, it's not that annoying, but as time progresses, it becomes more and more annoying, and it actually starts to slow down both your work as a developer and the entire business ability to move, because it slows down actual deals with customers that need these features. So while we definitely don't need to build all of the interfaces for control from day one, it is important to realize that other people, the product managers, security, compliance, the customers themselves, professional services, support, all of these people would need to work on permissions in some way or another. Because accessing the product is one of the most basic and critical experiences of any product. So you can start by providing a simple management layer. It can be something very silly, but as long as you plan for it and you can expand on it later, you're going to have a better time, as opposed to having nothing in place and having to refactor the entire thing just to be able to add it. So there are two kind of interfaces. You want one for yourself. Yourself is the organization working on this, and we often call this the back office. And later you want kind of democratized, more limited experiences for the developers, for the customers themselves. So, for example, do the distinction between the two, you want, for example, audit logs for yourself, where you can see all the tenants and all that they did within your product. But you want to be able to minimize it to a specific tenant, so that customer can see what they did on their own within the product, and they won't have to open a ticket for you to create a log that you send them over email or something silly like that. And lastly, I think the one of the best practices that I like the most is GitOps. So we're managing a lot of complex rules and a lot of performance critical and organizational critical decisions here. And with, again, we already said, with a lot of different people that need to chime in and affect this, or at least be able to gain visibility to this. And we need audit logs, and we need general logging, and we need review mechanisms and debug mechanisms for this. So we can try and invent a way to track all of these, or we can rely on best practices that already work for us as developers. And that best practice is managing things as code. So the moment you work with an agent like OPA or OSO or anything like that, you can generate your policy and save your policy as code, and then you can manage it as code in a Git repository. So just by putting it in there, you automatically get versioning. You automatically get the connection of all the tools that you're familiar with to do merges, to do code reviews, to do a CI process. So you can say, for example, so this is the branch we push policies into. This is the branch that we actually deploy. And between merging those branches, you can apply your test and benchmarks and the code review and any approval processes you'd need as an organization. And you don't need to reinvent them, and best yet, you don't need to learn them. You already know them because you know them from code. And as people become low-code developers, so for example, with Permit, the policy editor generates code. So it's a UI component that a product manager works with, but it generates code. So everything kind of comes down to those same best practices, even if you're not necessarily a full-blown developer. And it essentially creates a layer that connects everyone with best practices that have been proven across the space, both in security and just general code development. And yeah, and I like that one the most because it's maybe the one that I think makes the most sense as a developer. Don't reinvent the wheel. Like if there is something in place ready, just stick to that. No need to go and invent new stuff that you're not sure would be good enough.
Amazing. Well, thanks a lot for the detailed explanation. Or I definitely agree with a lot of points you mentioned, especially about being event driven as well. You mentioned Opal is it's an open source project started by folks at Commit. Can you maybe share a little more about how, like, what would be the next steps for someone who wants to get involved as a contributor, let's say?
Oh yeah. First of all, we'd love that. We already have some people contributing, and it's so much fun to work with different people around the world. And by the way, contributing it doesn't have to be just code or features. It can we also are looking for people to help with documentation and with supporting materials and tutorials and just help people in the community. So the best place to start is probably joining our Slack community, both at opal.ac and at Permit.io. There's a big community button at the top navbar. Just click on it, it takes you to Slack, and you can start chatting with us and the other people using the open source product and using Permit. Um, and on top of that is just going into Git, our Git repository. So it's GitHub slash permit.io slash opal. And under issues, you'll find issues marked as good first issues, which are just waiting for someone to pick them and start contributing. One of the things that I think are very cool about Opal is that it's almost exclusively at the moment written in Python. So it's a very lightweight language. It's really easy to get started. It's really easy to add more code. I think it's even a good spot for people that are kind of new to contributing to open source. I think both because we'll be very welcoming as a community and as managers of the project, and also because it's an easier language to start writing it and contributing in. On top of that, on top of those good first issues, there are things that Opal constantly requires more of in a very natural sense. So I kind of described Opal's ability to connect to different data sources. That's done through a plugin mechanism called data fetchers. Those data fetchers are basically small Python modules that teach the Opal client how to connect to different sources. So someone written a Postgres data fetcher, and someone else has written a LDOP data fetcher. And there's need for more for like a Salesforce data fetcher, a SAP data fetcher, a Neo4j data fetcher. Like there are a lot of data sources, both databases and services that people want to be able to connect data from into your authorization layer, and it's a really simple kind of separate component that someone can create and contribute. So yeah, to summarize, just join our Slack community, chat to us on GitHub, look at issues, open issues, start a discussion, and just pick something that you're excited about and just share it with us. We'd love to help you bring it to the finish line.
Amazing. Well, thanks a lot for sharing over. And for folks who are watching, I'll leave all the links in the description below as well, so it's easy to find and you can get involved. And yeah, to check it out, if you have any other questions, you can join their Slack community and you can ask your questions over there. And thanks a lot for watching. Really, had a great discussion with you. Or as always, a pleasure. And thanks for giving your time. And for folks, everyone else, check out the links in the description below. And we'll see you in the next one. Have a great day. Bye.
Thank you, Kunal. Bye.